Hello, my name is Stefano Faccin and I'm a director of standard at Qualcomm, and I belong to the Qualcomm Standard International Organization. I'm very happy to be here to discuss about enabling aviation use cases via 5G technologies. The UAV industry is growing dramatically. We are expecting a 30% growth rate in commercial UAVs between 2020 and 2025. In 2020, we shipped about 1 million commercial drones, which will grow to 5 million in 2025. And again, in 20, we shipped 10 million consumer drones with an expectation to grow to 21 million in 2025. So this growth is tremendous across the board in UAV application and services. Asset inspections is estimated to be a $15 billion business, and the utility industry is expected to be a $2.2 billion industry, which is, as you can see, big numbers. Now, what are the use cases? We can identify at this point mainly 5 types of use cases. The film entertainment unit and entertaining, the film and entertainment is an industry that is already using and has been using for quite a while this uncrewed system, including consuming flying cameras, movies and news media. It is being used for real estate projects, for sporting events, and it's an industry that is growing dramatically. Delivery, it's the promise, the big promise for uncrewed system. From package delivery to transport of medicine and vaccines, there are new projects started every day around the globe to use uncrewed system to support the delivery industry. Public safety is very important, including emergency services, providing cellular coverage for first responders, as an example, deploying base stations on drones in areas where there is no coverage, and to support search and rescue thanks to computer vision and onboard sensors on uncrewed systems that enable all these search and rescue missions. Agriculture is using uncrewed system for crops visual inspection, automated planting, distribution of chemicals to the crops, and livestock tracking. The inspection industry is using uncrewed system every day for critical infrastructure inspection, like cell towers and bridges, and inspection of hard-to-reach assets, where using humans would be very expensive and very risky, such as oil and gas industry inspection, wind turbines, and all the infrastructure that, as we said, is hard to reach. Now, what is needed to enable all of this? Well, we think 2 main components are needed. Cellular connectivity, because this will provide safety and operational communication for beyond operator visual line of sight, which will become more and more important for many of the use cases that we mentioned. It provides safety enhancements to enable autonomous or semi-autonomous operation. It enables media sharing and payload status updates, where there is streaming and offloading of the media from the flying vehicles to the ground receiver. And it provides a fail-safe link when the operator visual line of sight is not present anymore. So we could have drones that are flown in line of sight missions, but may now go behind an obstacles and not be visible anymore by the operator. Onboard intelligence is going to be very important to enable video photography with 4K and 8K capabilities, to enable autonomous navigation with vision recognition. And this brings us to the intelligence part of all of this. So to have machine intelligence on board these devices, to have computer vision, precise localization, and high fidelity sensor processing, from temperature to wind to LiDAR to radar, and all the sensors that enable navigation and the safety of missions. Bringing together all of these in a common flexible platform is for Qualcomm very important. We think creating a highly optimized heterogeneous computing platform is the solution to build a variety of vehicles that can satisfy all the use cases that we are seeing now in the market. In particular, we need to support compute-intensive and diverse characteristics, as we mentioned before, from machine learning to computer vision to different type of connectivities. And this would enable the creation of smarter, lighter, and safer autonomous uncrewed systems. Now, in all of these, we believe the leveraging 5G mission critical and massive IoT capabilities is going to be very important. What does this mean? This means enabling wide-scale deployment by you having uniform throughput. So scaling the connectivity to multi-gigabit per second with consistent user experience, providing bandwidth and supporting massive MIMO for the connectivity. This means providing coverage at all relative altitudes with uniformity and at different altitude and speeds, and optimizing handover of these devices in their connectivity to the network. This also includes direct communications, so direct UAV to UAV communication for services like detect and avoid, provide multi-hop and relay connectivity for safety and extended coverage. And in general, the idea of supporting high density of devices like in urban environments to have more efficient and reduced amount of signaling, such as device-centric mobility. Leveraging mission critical means enabling ultra high reliability of the communication, providing ultra high availability of communication by using multi-connectivity and redundant links for failure tolerance and extreme mobility scenarios. This also means providing strong end-to-end security. So to have a security enhancement to the air interface as needed to the connector, to the service layer, though we think 5G system already provides sufficient level of security, but also enabling what we call secure and verifiable identities, the ability to trust the identity of a flying vehicle when it identifies itself to service provider and to the traffic controller, so that we can provide more safety to these operations. And in the end, as part of the mission critical, also providing low end-to-end latency that would enable missions in scenarios where very reliable command and control is essential. Now, let me talk very briefly why Qualcomm and what Qualcomm has been doing about this to give an idea of how important we believe this is. So Qualcomm started a drone technology programs in 2014, and the first output of this was the Qualcomm flight platform in 2015. And this platform was adopted in 2019 for the first drone that performed autonomous self-powered flight on Mars. In 2018, we launched the Qualcomm Flight Pro platform. That was an evolution with many more capabilities. And this led to creating various robotic platform with the Robotics RB5 platform in 2020 that evolved in what we call the Qualcomm Flight RB5 5G platform and drone reference design. And what is now the Qualcomm RB6 platform that will become also an RB6 flight platform. And this has been a very successful effort, has been recognized by the industry as a set of platforms that really include all the features that are essential for enabling these vertical of UAVs, with more than 200 drone and robotic ecosystem members that are part of this effort. Let me talk briefly about the Qualcomm 5G RB5 platform, not so much to advertise the product, but to explain our vision of how we need to integrate a large set of solutions to provide efficient and effective solutions. So as I mentioned, this platform is a high performance and highly integrated system on chip that integrates a lot of functionality from vision and perception with 8K and 4K cameras. It has digital zoom, horizon leveling, multi-camera concurrency. It includes 360 obstacle avoidance with depth estimation, obstacle detection, and mapping. It enables a high degree of autonomy with visual inertial odometry, path planning, PX4, GPS denied navigation, support of beyond visual line of flight, and follow me capabilities. It provides different types of connectivity, 5G, LTE, long range Wi-Fi included for communication to the ground, communication to the controller. It includes computer vision processors to provide depth constant stereo, multi-object detection and tracking, and a digital gimbal. And it's an open platform that can support various operating systems. We believe these type of platforms are what are going to provide OEMs the ability to build successful UAV products. Now, in the previous slide, one thing that I didn't mention explicitly is a technology that is being created, the technology that Qualcomm calls U2X, or UAV to anything. This technology is meant to support mostly two types of application, but it's open, of course, for additional application. At present, these are broadcast and multi-D that is required in North America, and that can be used in other parts of the world to identify the flying vehicles, to ground the units that may belong to the police, traffic controller, or any other authorized observer, and enables device-to-device communication to provide what we call the aircraft-to-aircraft component of a successful DAA solution. This builds on 5G standards that have been designed since release 15 and are still in the process in release 18 to enable this for flying vehicles, and is being considered in other standards that have been discussed at present and on which I will have some slides later. The key point here is that we are planning on utilizing the experience and all the learned lessons from the automotive industry in their support of cellular V2X and repurpose it as appropriate, in particular with increased security, for the aerial vehicles that can be unmanned aerial vehicles or advanced air mobility. Just briefly, you've seen that I've been talking a lot about uncrewed aerial vehicles, so traditional drones, but all that have been said so far applies also to urban air mobility or advanced air mobility. The format factor will be different. The passenger will be a very precious cargo, but all the aspects that we mentioned before will apply as well to these type of scenarios. Now, what are the building blocks for success as we see them? Well, improved connectivity is a very important building block. The two key questions here are, is the connectivity going to be good enough? And is the connectivity quality of experience being maintained? The first one is to support mission planning. When a US operator needs to plan missions, when the traffic management functionality to support an approved mission, it's going to be important to know the level of connectivity that the device will maintain. So being able to answer this question with mechanisms provided by the industry and with standardized solution is very important. And efforts are ongoing to standardize these solutions. The second question is to enable continuous QoS monitoring and exposure of the QoS levels that devices are experiencing to the US operator in order to possibly change flight planning or to take measures. The other building blocks is a scalable and flexible C2 connectivity service provider model. We think a model that can be supported by mobile operator and UAS operators, it's very important for scalability and for reliability. And we think that the C2 CSP model needs to enable identification, authentication, authorization of UAVs and ground control stations from remote. Specifically, what I mean, we should move away from semi-static pairing of controllers and flying vehicles and enable scenarios where we can enable a more dynamic pairing of UAV and ground control station in a one-to-one or end-to-one model, depending, of course, on the level of autonomy. Specifically, to give an example, we should enable scenarios where we had drone-in-a-box solution deployed around our urban area, and we have ground controller systems that can be very remote and that can be paired dynamically for different type of missions without needing any specific intervention on the UAVs or on the controller, but by having a C2SP system that enables a dynamic pairing by using security solutions that will enable to avoid hijacking of the devices. And the C2SP model will be needed to manage data flows for command and control, telemetry, navigation video, payload video, and including transfer and multicasting of these videos are required by the use cases. The other three building blocks that we think are very important are a scalable and secure detect and avoid and collision avoidance solution, or as they call it in some scenarios, collision mitigation. This is what I was mentioning before, a solution like U2X, which the industry will probably name as aircraft-to-aircraft solution, is going to be important. And we think the ability to have reliable communication between these flying vehicles integrated with network assistance solution, the leverage mobile network connectivity and edge computing are going to be the answer to creating safe systems and to create a scalable and security solution. And there is working standards that is ongoing or is starting to enable all of this. The other aspect is spectrum. When we want to use cellular connectivity, we can surely use the commercial spectrum that is available to mobile operators, but we need to do so efficiently without creating too much interference to existing devices and navigating the regional regulations that may prohibit certain spectrum to be used for flying vehicles. So there needs to be a concerted effort by the industry to identify how to use this spectrum. But in addition to this, we believe it's going to be very important to have dedicated bands when available, and bands are being made available for this, for UAV2 communication and to support command and control connectivity, in addition to the spectrum that is currently available to mobile operators. So there are regional efforts all over the world to discuss these spectrum issues, and we think it's very important to have a uniform solution that can be adopted in various regions. The last building block that we think is very important is the use of cohesive regulations and standards. And let me talk about those. So here I'm going to mention three specific efforts, but there are many more than these. And of course, I'm slightly biased on European and North American centric standards, but some of these are actually global standards. One of them that I mentioned before is 3GPP. 3GPP is inevitably brightening the standards for mobile operator networks, for 5G networks and evolution of them, and is focusing on building blocks for cellular connectivity and PC-5 solution for both uncrewed aerial vehicles and advanced air mobility. And there is much more effort that needs to be put into this, and there are many projects that we believe needs to be carried out in 3GPP to provide these solutions. RTCA and EUROCAIS are working in parallel, but also jointly, to defining requirements for C2 connectivity. So how to use cellular technologies for providing command and control. By defining requirements that then devices and network will need to satisfy to have reliability and safety. They're working on defining detect and avoid requirements because they're different from the detect and avoid and collision mitigation solution for traditional commercial aviation. They're working on defining the UTM overall ecosystem and on solutions for network remote ID, where devices will report constantly their information to network servers that will then collect and process them and make it available for traffic management, for public safety, and so on. An activity that is particularly dear to me because I've been part of founding it is the ACJA, so the Aerial Connectivity Joint Activity. This is an effort to put together the mobile network industry and the traditional UTM industry, and it's joint activity of GSMA and GUTMA. So any company that is a member of either GSMA or GUTMA can join the ACJ effort, and I strongly invite companies to join this effort. And I will mention some of the work that has been done and some of the work that is going on and that we think is going to be essential. So work task one has written a published document that describes how 3GPP cellular networks can be used to support UAS operators. And this builds on top of the standards up to release 17, describing how the tools can be used to enable the use cases. Working Task 2 has defined a reference method for assessing cellular C2 link performance and a RF environment characterization for EOS, and this work will be evolved to provide even stronger method, and has defined an interface for data exchange between operator and the UTM system. So this would be the data system that, as I mentioned before, would be used to allow US operators and UTM to monitor, as an example, the QoS of devices or to do the flight planning. Working Task 3 has defined an LTE area profile that is now being taken by GSMA to be published as a document for to describe how devices should be built to satisfy the aerial scenarios. But there is much more work ongoing and much more that probably will be started. And we believe we need wider participation by the industry in all the regions of the world for the AA and broadcast multi-D to support the UAV ecosystem landscape and to support cellular connectivity requirements. So these are the building blocks. These are the standards we think are important, and we think this is the work that needs to be done. That being said, I want to thank you for the time being given to me, and I hope you found this material useful. And with that, I will say goodbye.